Hello viewers, in this lecture we're going to cover the angular velocity. If you haven't seen my previous lecture on the angular displacement, you should go and watch that first. If you have learned the concept of the angular displacement, angular velocity is just a piece of cake for you. Just leave the angular for a while. Talk about the simple velocity. V is equal to d upon t. Here d is displacement and t is the time. What if I add a, that probably means angular, within both of the quantities, as well as velocity too. So this is the new definition of angular velocity. Something new? Keep that in mind. Whenever a thing is just rotating in a circular motion with change in the displacement, like a body is moving from here, then here, then here, then here. This is what? This is change in displacement. So this is referred with respect to time, that is called angular velocity. Easy, right? So if you're going to have focus on the figure here, so basically you can see here the definition of the angular displacement. The definition of the angular displacement is written here just because we are talking about the change in the displacement. That probably means a body is making first arc here, then second arc here, then second arc here. It will cover the whole area of 2 pi. That's why it is also referred to the angular frequency. Now how I'm saying angular frequency? The displacement is covered with respect to 2 pi divided by change in time. 2 is non-dimensional quantity, pi is non-dimensional quantity. We are left with 1 upon t, and that is equal to f. We also referred it by 2 pi f. That basically means 2 pi divided by time. Easy, right? Let's move on to its proper definition. So here, change in velocity per. Here should be per. I don't know why they haven't added the per. So omega here, the omega is equal to change in displacement per unit change in time, where the omega is the angular velocity, the theta shows us the angular displacement, and change in time is change in time. Angular velocity is measured in radian per second. As you know that theta is denoted by radians. Per unit time means per unit second. And we are done with the radian per unit second. That is an SI unit. One complete rotation, as we know, is equal to 2 pi radians. And how many degrees? That's question for you. Therefore, if an object completes an rotation, revolution, keep that in mind. Revolution basically means a complete rotation of the whole circle. Like a point is standing here and she completes one rotation, that is termed as one revolution. In per unit time is called angular velocity. Here the one revolution is known as the angular displacement, while the time is given by change in theta, that is equal to 2 pi revolution. And the angular velocity is, we know that change in theta per unit time, that is basically, if we according to this example, theta is equal to 2 pi n, so here we will go write 2 pi upon t, so it will be angular velocity, angular frequency. I hope that you get all the points that I've told you. Thank you so much for watching this video.